Today, welcome everyone first again. Today we are going to talk a little bit more about mappings. So the lesson we are going to talk about is in the section of how-to guides and mappings, and is this one, which is currently called "Are These Two Entities the Same?" But I think we can find a little bit more fitting title later on. But remember, all of the materials we put together, especially some of the more kind of like experimental and new materials, they are also a bit work in progress. So it's possible that after the discussion today, some sections in here will be ditched and replaced by your better judgments that you put forward. This is more kind of like an attempt to formalize the problem of designing and putting together a mapping project. So where you have two resources and you want to say, how do I actually set this up from the start, and how can I actually figure out whether two entities are the same or related in a specific way according to our mapping relationships. So yeah, read it and listen to it with that in mind. This is not gospel. This is just, like a first attempt to formalize this. And if you feel like I've been missing certain important resources out there that I should have folded in, or if you think like this approach is also not so, well thought through and crappy in certain places, and please just tell this to me, and we will sort it out together and make it better over time. All right, so how do we, just give me 1 second to get rid of this lights behind me, because I see it flashing all the time in my screen. Give me a second, sorry. All right, much better. So the basic protocol that I propose here for, setting up a mapping project, so where you have something like, I want to align these two ontologies, these two resources, these two what Charlie and I are trying to kind of like push as a name, these two semantic spaces with each other. So what are the steps you want to go through? So the first proposal is like this. So first we do something. We try to understand the conceptual models that are underlying these two semantic spaces, which is basically about figuring out, okay, what exactly was the intention? How does this terminology, this ontology, this database, and so on supposed to relate to the real world concepts? Then we document the use case for the mapping, which is something that is quite important for certain decisions, especially in the steps that are following that. Then we define some of the basic overarching curation rules. For example, we make what is called conflation decisions over certain entity types, and decide which mapping predicates are appropriate. And then we get into the phase that is what most of you are probably interested in, which is the phase of gathering evidence for and against the mapping. All right. So I'm just going to scroll a little bit down and go up again, just to remind people, because there are some of you may not know exactly the context of what we're talking about here, but I just want to just remind ourselves what a mapping actually is. So many of you have seen this a million times. Just going to say it real brief. What we refer to as a mapping, or more precisely an entity mapping. So we have, so in our kind of like understanding, we say that entities are symbols, like codes in a terminology, like, for example, ICD, or classes in an ontology, or enums in a data model, or even simply strings in a text field of some database that are intended to refer to some real world thing. And when we say an entity mapping, what we mean a correspondence of a symbol, for example, in this case, in this relational database, the string of Friedrich's ataxia that is, for example, used in this EHR record or something, is corresponding to this, OMOP identifier that is used in this Excel spreadsheet somewhere to describe clinical data. And yeah, so that's kind of like the main subject of what we're talking about here. So I'm going back. All right, let's go through the phases. I'm going to make a brief stop after each major phase, but feel free as always to just immediately interrupt me. And Sarah, if you see kind of like people saying something in the chat, just interrupt me, so that because some people may not feel, you know, confident enough to just stop me in the middle of talking. So you can all just comment in the chat, and Sarah decides now is the time to interrupt me. All right. Okay, so conceptual model. So the checklist, kind of like this is how I describe it. How do we kind of get slowly to understand the conceptual model of the space? So let's start with some like very basic questions. These seem very obvious to many, but they help us to narrow down what we mean by a conceptual model. So we start obviously with saying, okay, what is the original domain of the semantic space? So remember, semantic space, terminology, ontology, database, and anything that coins identifiers to refer to real-world problems. So is this like medical research? Is this a clinical space? Is this environmental, and so on? So just note it down. I would recommend, you know, when you're planning a mapping project, to really just write this stuff down quickly, and doing this here will take you maybe like less than an hour, so it's definitely not lost time. The next is to determine the organizing semantic framework. So in case it's an owl ontology, then it's an owl ontology. So that's one kind of organizing semantic framework. Then we have Scott's taxonomy, but many of the semantic spaces we deal with actually don't have a specific semantic framework underpinning it. But even in these cases, we really at least write down, okay, this is a database, this is, and we have maybe some semantic schema associated with this database, which would even help us understanding the intended conceptual model underlying it, or even just a normal database schema. Then one thing that is, you know, maybe not strictly necessary, but it helps really a little bit later in the process as well, is to determine what I call the primary organizing relationship. So as you know, these kinds of resources, even if they are not ontology strictly speaking, like ICD, so in International Classification of Diseases, or UMLS, and so on, they may not they're may not like OWL or ontologies in the very strict sense of the word, but they still can have like a lot of different relationships between entities. And what I mean by primary organizing relationships are the relationships between the entities in the semantic space. So let's say you have something about diseases, then what I just want to kind of like document here is, how are these diseases organized with respect to each other? So in many cases, this for some ontologies, like for example for Uberon, which is an anatomy ontology, you will have most of the kind of entities organized using mereological relationships, like part of. Or if you are in an ontology like the more traditional style ontology, then you will have mostly the primary relationship that organizes everything will be the subclass of relationship. And but if you're in the taxonomy worlds, you have like scores broader, narrower. You may have in a database world, you may have some relationships like isomer of, functional group of, and so on. So for chemical entities, but you know, for now, just writing this down to have a sense. Okay, this is how this, you know, the entities in my domain are organized with respect to each other. So in relation to each other. Yeah, remember here that this is already a bit foreshadowing to the next steps, but remember here that the primary organizing relationships, that's something that we as ontology engineers need to remind ourselves of. They are not always intended to reflect knowledge. So it's very often the case that they are like derived from like a very functional use case. Like for example, in ICD-10, the primary relationship is these like SCOS-like broader narrow relationships between categories and disease terms. But we have certain features here, like we have a requirement for it to be mono-hierarchical because we have mostly billing and statistical purposes for which this ontology is used, and so which means that a lot of like biological ambiguities won't be reflected in such a terminology. Just, you know, keep this in your mind that when you're writing this stuff down, some of them are intended to reflect knowledge, others are intended to really be kind of like related to a use case more than it is to you know, organized knowledge. Then, of course, what are the primary categories that are reflected by a particular space? And lastly, what is the conceptual model that is underpinning the primary category? So, for example, I say here this is the most difficult part, but it is actually super hard, mostly because in 99% of the cases that you have to deal with, you will not know what the exact conceptual model is. So you will, for example, let's say if I tell you now, please go and tell me the conceptual model of ICD-10, what you will do is you will have to start reading the website, you will start reading the associated papers, trying to get a sense of what they exactly mean by a disease and whether they are using I don't know what was written here, like a biopsychological model of disease or a biomedical conceptual model of disease, all of these kind of like different kinds of disease. So what this means is that if you have an instance of that disease defined in this space, it's defined in terms of specific attributes. Like, for example, in some models of disease where you're primarily looking at how does the disease appear to the clinician or how does it manifest itself, you have like a phenomenological focus. What's the associated phenotypic profiles, and in other kinds of classifications or spaces, you are strictly looking at etiology, so looking at how does the disease emerge and what are the reasons for the disease to be what it is, more than how it appears. And there are many, obviously, different models across different data types, chemicals, biology, anatomy, and so on. All right, yeah, so here a quick example. So this, I've already said some of these things in the description before for ICD-10. So Mondo is an ontology focused on modeling diseases with a bit of a special focus on rare diseases. In ICD-10, we have a comprehensive system for coding diseases, but it also covers other things like symptoms, signs, abnormal clinical and laboratory findings, injuries, which are also covered by Mondo, by the way, and other things like external causes and factors influencing health status and other things. In terms of organizing framework, we said Mondo is an owl ontology. ICD-10 is actually difficult to classify. So when I tried to do it, you can sort of say that if you're looking only at the primary organizing relationship, you can sort of say it's like a taxonomy. But if you look around, there's a lot of different other relationships in ICD-10. So it's like, you know, a very weird hybrid, actually. But yeah, the primary relationships can be classified sort of as a taxonomy. Yeah, we've talked about the primary organizing relationships, the categories as well, and the conceptual model. So after a little bit of research, you find that, for example, in ICD-10, there is no kind of like a very strict commitment to a specific model, and they say, yeah, we don't want to kind of nail ourselves to a definition of disease 100%, so they keep it a little bit more like broad and open without a very, very strong commitments. And I think this is sort of reflected, and I mean, I'm probably not exactly, I will be shot by some clinicians that are working on like Mondo and DO, but I think generally we are a little bit more open with our definitions of what a disease is as well. All right, this is just like a quick snapshot to get this into your minds of a tiny fraction of a disease model, so that you have like a picture in front of you that looks a bit more, that gives you a bit of a sense of what we mean by model. So here, this is only a very small part where you see, okay, there is a disease. The disease is a medical state. You have other states like susceptibility to disease and injury, and you see they're not classified as diseases. This is one important piece of information for the conceptual model, because there may be another kind of ontology that puts them all into the diseases branch and kind of like puts them all together and interlinks them and so on. We have specific diseases and disease grouping, so there's a distinction between those. You can also see down here, there's diseases that are grouped by site and diseases that are grouped by, for example, heredity. And there are actually also diseases that are grouped by both of these. So this gives you a bit of a sense that, yeah, there is a bit of a sense of holy hierarchies here as well, and that, you know, diseases aren't like, you know, mono-hierarchical, like in the sense of ICD-10. All right, so let's take a quick...
Harry just put a comment in the chat if you wanted to check that out. It's not really a question, just potentially.
Yeah, very, very minor observation.
All right, do you want to say that, Harry? Just say it by yourself.
Oh yeah, just one thing that I noticed in working with ICD-11 before, which is even weirder, that they explicitly say that they put codes next to each other so they can be easy to look up. Like it's very, I don't know if that actually works in practice, but it's, you know, another one of those things that really define the underlying structure of it that I do not think is the case with Mondo.
Yeah, so in ICD-11, there's actually a more interesting situation, because you have the kind of the foundational module, which no one ever sees, which is like the sort of like what you could call like the semantic core, that from which these linearizations, like ICD-10-CM would be one of these, like you generate those kinds of linearization with like, which are mono-hierarchical and so on from this like semantic core. And there would, in here, if you would have to, so let's say someone gives you the task, align your ontology with ICD-11, you would actually have to first research and figure out, oh man, there is actually like a semantic core underlying this, and you actually can get a little bit of a better sense of what their disease model is by looking at that core, and which also has actually polyhierarchical elements as far as I remember. Cool. Any other questions about this part? So we have our two semantic spaces. We have gained some understanding about what is the one about, what's the other about, how do they perceive the entities, what do they think of those entities that we seek to map to each other. And we have a bit of a picture now, so that gives us a strong spot. Usually we have in the past not really bothered with this part, but I think given the fact that you can do this in a reasonable amount of time, this is going to be super useful for documentation later. So is there any further question about this part? Do you agree it's necessary, or do you think we should never do this? It's fine by me if you're against it. So, all right, excellent. Let's move to the next part. So documenting the use case of the mapping. So when we are documenting the use case of the mapping, so why do we even want to write this down? Like you heard many of the SESM developers, including me and other people that have presented about this, constantly say about the mappings should be universally true. We don't need use cases and so on. But the matter of fact is actually that use cases drive a lot of decisions for your general semantic space alignment strategy. So for example, which kinds of mapping predicates do you actually care to curate? Yeah, for some use cases, like the one that we are discussing here, for example, related matches and narrow matches are totally irrelevant. So there's no point to even think about those, and there's no need to write them down. So we only care about, for example, broad matches and exact matches, or we only care about exact matches, which is also, there are also use cases for this. So in this case, it's useful to know your use case before you start going, and every mapping effort always starts with the use case. The use case also dictates whether you should or should not conflate certain things. So conflation is what we will discuss later, so I will go and get into that when it comes. It also answers questions like, how broad should you map? Like, for example, Sue, I don't know whether she's here today. She's asking the question like, you know, how far broad a mapping is still useful to the people that are using the mapping, for example, for data science tasks, and when does it get so broad that it is mostly irrelevant? So that kind of, this is also dictated by the use case, how far you want to go, how broad you want to go. And also which levels of evidence you would consider acceptable. So this is the last part of today, where we will go through, where we discuss exactly evidence gathering, how it relates to confidence, and how we can make decisions about what kind of evidence we need to gather. All right. Yep, so let's go to this example use case here. So for example, in this use case for today, we have the typical Mondo slash CPath slash Monarch initiative slash many other knowledge graph integration initiatives, let's say, that we want to build a knowledge graph that integrates information about diseases. And one of the key features we have in this knowledge graph is that, and there are knowledge graphs where that's not the case, but in ours, because of the kinds of applications and the kinds of analytics we want to run, we want to make sure that every single disease that exists out there is reflected in exactly one node in that graph. So when you have something like a case like this one, where you have the same disease like Friedreich's ataxia being referred to by DO, by GARD, by Ordo, by OMIM, and by MESH or something, then we want, one of the properties of our use cases is we want those to be in one node in the end of this process. So, and in order to be able to do that, we are primarily interested in exact matches. So very related to that, there are some kind of basic analytics we want to enable. So one of the kind of like really, so for you it sounds boring, but it is a super important kind of analytic, is to be able to count. So for example, in rare disease, it's always a kind of like, you know, tug of war a bit. How many rare diseases are there currently that are being documented? And in order to make that kind of counting, you have to count across a variety of different resources that document rare diseases. And you can only count accurately if you know which ones of these concepts correspond exactly to one another. So that's our use case for today. So is there any question about that so far? Does there anyone who doesn't agree that we should know the use case before we start with our mapping?
I have a question or comment, so that
okay.
somebody interrupts you. So I obviously agree that we do need the use cases. How do you reconcile the fact that one group might have a use case and another group might have a different use case, and that when those different use cases do not match, what what do we do about that?
That's a fantastic, absolutely fantastic question. So this is actually the core kind of like message that we try to get across with standardizing our mappings and enriching our mappings with metadata. So in recent years, when I present SESAM, I try to kick one message home, which is we try to enrich our mappings to an extent that the metadata we are providing gives enough information so that we enable cross-purpose reuse. Okay, so the fact that we have produced these mappings for one use case does not mean that they are not usable for another use case. Yeah. So, but if, for example, we say in our use case, okay, we mostly rely on exact matches on the label. We don't really care about all these like fancy full expert reviews of mappings that identify these like tiny pieces of distinctions between concepts. And then we can document that clearly and say that we have all our mappings are associated with a lexical matching score, and someone else that wants to do mappings for a completely different purpose can see that and see, okay, these mappings are justified using lexical matching. So we can take that and fold that into our own pipeline. But for example, here you have used semantic similarity threshold matching, which I find so risky as a user that I don't want to take those into account. So I will leave those to the side, and I will only take your exact matches and move forward from there. It's okay, Sabrina?
Yeah.
I
see there's a comment from Chris. I'm reading it, so I cannot tell you.
Chris,
yet
you can also speak up. Speak up.
I don't think he actually has a mic capability today.
All right. Okay, so yeah, so and he's worried about analysis paralysis and the preventing us to making practical and useful mappings. So I think again this is again related here, and you will see it also in the evidence gathering, is that you can get some practically useful mappings with low levels of evidence that can be used for many different use cases, but may not be suitable, for example, for something like a clinical billing use case where you want to know if you find a SNOMED code in an input, which exact ICD term you can link that with so that you can run a billing. So this kind of thing requires a different level of like curation than and a different level of analysis, which you would probably call paralysis, than more sane biomedical data integration, which is more like this use case here, where we may be able to kind of deal with a little bit more noise and live with a bit more noise, actually. All right. Okay. So now the basic curation rules. So we decide, of course, which kind of primary categories we want to map to each other. So not all of the terms in the semantic space we are looking at may be relevant to us. So for example, in Mondo, we only care about diseases. So what we do is we say, when we inline an external resource with Mondo, everything that's not a disease, we are not aligning it. So we don't care, we exclude that. Actually, we have specific exclusion lists that allow us to say these terms, even if the other resource said it's a disease, we don't believe it's a disease, and we document that somewhere clearly. So this is the first part, is to say we are only caring about diseases, and that's what we will focus this part on. Now, the next step is we want to decide whether we conflate the kind of like conceptual models of the two resources. So most of the time in biomedical data integration, if the two primary categories are the same, sorry, this is point 3, then we most of the time decide that conflation is okay. So for example, you say you align ICD-10 with Mondo, you say no matter what ICD says a disease is and what Mondo says a disease is, or no matter whether this is, so these are separating between disorders and diseases, and this is separating between only diseases or something. So we decide that these two resources, we just usually say it's okay to say no problem. These we just conflate here, which means when you have Friedreich's ataxia, let's say, appearing in one resource and Friedreich's ataxia appearing in the other resource, we just say they're the same. That's very practical, and it's totally fine. But there are many examples where there are problems with that kind of approach. So for example, here put an example down here, which may or may not be a problem. We don't, and this is what Chris also is warning of, like with analysis paralysis. So we have a concept called nocturnal enuresis in Mondo, which is defined as urination during sleep. Let's not even discuss whether this is complete, incomplete, missing some stuff. It doesn't matter. So this is like what it is right now. and it's classified under psychiatric disorders, while in ICD-10 we have a term with the same exact name that's classified as a urological disease, which is explicitly organic, where it says even that that only physiological conditions are accepted, and if there's not a known physiological condition, then this is not applicable. So you see, there is a bit like, you know, if you're making a conflation decision, you also decide basically that this kind of thing, you will probably not even ever see it. So, okay. So then the next is conflation between different categories. So let's say you have the genes, that's a classical example that Chris is always giving, like genes in one resource and the primary protein products of the genes in another resource. So here you can make the choice to say it's that you can conflate those two because they have a very strong one-to-one relationship with each other, even though they are, strictly speaking, different things. And yeah, if you are decide you can conflate, you can. That's the good thing about this is you can just use standard mapping predicates. So if you say I'm conflating these things, you can just use scores exact match, scores broad match, and so on. And another source of conflation, which is sometimes we make a bit of a distinction, we decide not to conflate, is mapping across species. So if you map between MP and HP, for example, you may conflate or you may not. Yeah, and then you write down what's the minimal levels of evidence that you expect for each of these mappings to be true, to integrate it and to take it into account. All right, let's jump a bit forward here. These are some explanations and some further examples that you can use, but I want to make sure that we have a lot of time for the next section. So I'm just jumping into the evidence gathering section, which is, even if you ignore everything that came before it, I guess this is the kind of like key piece here. So the first thing that we need to remember is that there is no way that you can't determine the correctness of a mapping. Yeah, so this is basically due to the fact that the conceptual models that are being used are kind of murky. You will never exactly know what the one person means by this nocturnal urensis or whatever this was called, and the other person. So there is no way to determine the correctness. But you can define levels of evidence that you accept for yourself to say, this makes my mapping okay, or this makes it good enough for my particular use case. And so the goal of this evidence gathering process is basically to increase your own confidence in the mapping. We, in the kind of area of SESAM, we define a single piece of evidence for a mapping as a justification. So we've written a lot of stuff about what these mapping justifications are. The confidence that you gain by collecting those justifications, it can be cumulative, it could be mutually exclusive, and so on. So you need to think a little bit about how they relate with each other. But this is kind of like the process. So you decide a bunch of justifications and that you want to take into account for your mapping effort, and then you work your way through them. So let's look at this a little bit. So what are the kind of criteria we need to consider? For which justifications to even think about at first? So obviously there's a level of confidence that is induced by a particular justification. So for example, this is something that also you have already reflected as a first order, forgot the word for this, but it's reflected directly in the configuration of something like LexMatch, in particular the configuration of synonymizer, where you can, but also LexMatch particular is where you can say things like, if you encounter a certain match, like match on the primary label, this gives you that much confidence. Yeah, so these kinds of things, this is the first kind of property that a specific justification can give you. It gives you confidence. Another thing is it has a cost. So some of these justifications are extremely cheap to generate. So for example, because in this case, we have cheap, fast standard algorithms like oak. So you can just run oak lex match, put your two ontologies in there, and boom, you have a reasonable mapping. And then you have some kind of level of confidence that you gain when this justification is met. And obviously, this is all something that you need to kind of decide for yourself based on your specific use case. But for example, in Mondo, when we have like an exact match on the primary label, we say 99% confident that this is correct. We know it's a low cost, and we just basically always match. When we give minus a little bit of QC on the side, we basically accept exact matches on the label directly in. But as you see with nocturnal Urances, you may make mistakes if you do that. You start with a confidence of 0, and then you go step by step through these processes. So I just ordered them a little bit by how hard they are, but you can order them in whatever way you want for your own protocol. Okay, so you have sameness of synonyms. So this is kind of the next step. So here you say, okay, synonyms are a little bit less trustworthy than primary labels, and in some resources they are where you don't really distinguish between exact, broad, and narrow. They are actually very much less trustworthy than matches on the primary label, but they are still very valuable indicators. So you can give yourself a boost of confidence basically when you have a match on the synonyms. It's still a super fast process, super cheap. Everyone should basically have a pipeline running that checks this as well. And the next one would be a proxy mapping. So let's say you're lucky that you have like multiple, that you don't have only 2 semantic spaces, but you also have already existing mappings to and from those semantic spaces. Then you can take them into account into your pipeline. And let's say you have your ICD 10 and you have your Mondo, and then there is one other resource out there that is both mapping to Mondo and ICD 10. Then you can exploit a proxy mapping, or if you or even if both of these resources happen to map, for example, to Orphanet, you can exploit these proxy mappings in your pipeline as well. So again, we have a good gain on confidence here, medium to high, because obviously we don't know most of the time what kind of like mapping justifications they have been using. If we knew that they were using SESAM and we knew they had a proper kind of like model like this here, we could obviously have a very high confidence based on that, fold it in and be happy. Again, super cheap. You start with it. Everyone should just do that before they even go into the harder part. So which slowly start now. So now the next step is to exploit similarity. So you can start with something like similarity on the primary label. So if you're in the clinical domain, you know that there are like some subtle differences between the ways that the labels are written. You can so some of them you can kind of catch them with pre-processing, like for example whether type 1, type 2 is written with Roman numerals or with these with the Arabic ones, or other kinds of like hacks, let's say, that you can put in the pre-processing and then it goes in one of the top bins. But here it's more like, maybe word order is a bit weird, or some kind of other kind of things you couldn't catch before. So you can run similarity, and maybe if there's a very high level of similarity on some lexical measure like Liebenstein distance or something, you can decide that it's maybe enough for you to include that mapping as well. So you didn't catch them in the first 3, but okay, maybe you have a match here. Maybe for your use case, it is tolerable to use it. Probably you don't want to, just put an exact match in this case, but this is again something that you need to decide by yourself.
Nico, there is a comment from Chris about labeling, if you want to just check that out and see if you want to also respond to that.
All right. So Chris says extremely distrustful of same label exact match in the domain of disease. In the pipeline we have in Mondo, it's a bit more strict than what is a bit more strict than what Nico says, but it's a good heuristic when aligning to a pre-existing ontology where you check for inconsistencies with existing mappings. Yeah, okay, so let's say in this case, the way that we usually act is that when a new match comes in, we have like a level of like curation going through those matches and like at least someone browsing through it before we fold it in. But yeah, it is a decision that you make basically whether it is good enough or not. But yeah, it's not really a minor point, Chris. I think it's a very important point, and many people will absolutely agree with you on this. So thanks for sharing. All right, so the same kind of like structure for similarity of synonym. You can again do something here, and now you're getting into kind of like the more murky and much more harder areas of mapping. So we start with hierarchical comparison. So hierarchical comparison, which is something that's like often applied, you know, subconsciously when you are a human curator. So I recently started working a bit more with my mother, who is a clinician, and you know had her review lots of mappings, and you could see that, you know, without being kind of like instructed otherwise, she would always take the kind of hierarchical structure very serious when she looks at ICD, when she looks at Mondo, because she doesn't, you know exactly how she should interpret, for example, two completely different primary organizing relationships from each other, like ICD's taxonomic structure and Mondo's ISA structure and other kinds of structure. So she would take it very seriously, and what she does is she checks, okay, what are the things that are subsumed under that code, for example? What are the things underneath, and are the same kinds of things underneath subsumed by underneath by Mondo? And are they in the same branches, or what are the parents? Are they the same? So this is generally a typical kind of what we would say in hierarchical comparison thing. Here, I'm just saying that the cost could be high, could be medium, depending on whether you find some kind of an intelligent way to implement at least partially this automatically. We have not done this. So basically, once we hit this state here, we are already in like human comparison land. And we are already at a point where we really need experts to look at what's happening, because we just don't have the algorithms right now to make a comprehensive, at least not, we have the algorithms, but we don't have them folded into our pipeline, at least for this particular example. And yeah, so this is kind of like the next step that happens quite often in the evidence gathering, is to just, you know, check how they are hierarchically related. All right, and then we go into these kind of like really hardcore areas. So this is where you have domain expert review of definitions. So definitions is what we mean by this is if the two semantic spaces happen to provide formal definitions, and it's very, very important to distinguish formal definitions from descriptions or something, then what you can do is you can show those definitions to a clinical or domain expert, and they can compare those definitions and mentally reason about those definitions and decide based on those definitions whether these two concepts are the same kind of thing. Very rarely do you have two resources that have formal definitions for their human readable definitions for their diseases, but if you have it, you can do that. And this is still a little bit cheaper than the hardcore final step in this pipeline here, which is full domain expert review. And what they do, what in this case happens is the domain expert looks at both of the concepts, goes to the various resources talking about them, looks in OLS, looks in the ICD-10 browser, checks out what additional resources say about these concepts. Are there associated publications? You take a look, what do the publications about, blah, blah, blah. So it can be, so I have asked my mother, for example, to document how many minutes do you spend on mappings exactly when you're doing a mapping review. And, you know, some mappings are, let's say, are 2 minutes, 4 minutes, 5 minutes, or something like that. So that's kind of like the normal range. But then there are some mappings that are going into like the 40-minute range. And you can see that if your goal is to map like thousands and tens of thousands of classes, then you really need to be very, very careful about this. And from my perspective, at least, I've seen a bunch of human expert reviews. There's also a huge risk that if they are not very well trained in like semantic mapping, they're actually worse than algorithms are, because they just don't have a sense of what exactly we mean by something like an exact match or a broad match or a narrow match or something like that. So it is a very, very hard choice here. And if, let's say, you need to resort to full domain expert review for your mappings, then it is a very good idea to send those people that are doing those mappings actually to a proper semantic mapping course where they learn exactly how they need to perform this mapping review before they can accept a mapping in. All right, that was.
Sierra has a question. Sierra, do you want to just ask your question?
Yeah, sorry, I hate interrupting you, Nico, because you probably answer my question as soon as I start talking, but I will ask it. So so when you say level of confidence gained, medium to high, is that a stand-in for like level of usefulness of this mapping? Because sometimes I see like, you know, I guess I'm just echoing what Chris says, analysis paralysis. Sometimes when you get into these higher level reviews, is that we just spend many hours talking about it, and then you know, it ends up that we have to iterate on the mapping anyway because somebody comes up with a new use case. So I guess in the back of my mind, does medium to high confidence mean medium to high usefulness, and we should go through this process? Or does it mean medium to high confidence, but usefulness depends on use case?
Yeah, so it's a good question of whether confidence and usefulness are correlated. So in the end, I think they are in some sense, because you remember that there is no general confidence score, but only a confidence score that you define as part of your mapping protocol. So given your specific mapping exercise that you're in, you will say the exact label match will give you a very high level of confidence. And usually that is sort of kind of correlated with how useful you would think the mapping, including this particular mapping, will be. Useful in the sense of I'm not including something wrong, right? Like, so I think it's a bit of a, I think yes, they should be mostly correlated with each other. And maybe, do you want to define usefulness here? Maybe one moment.
Yeah, I think that's my key. So when I'm looking at a mapping, so I'm coming from not ontology point of view, but like BioLink model, which is kind of, you know, a higher level thing. But if I look at usefulness, I often see my users come in and say, I use mappings in the model to figure out whether or not I can go to a different external resource and read about it and understand the concept better. Or I use mappings to know whether or not I can bring this data in and use it as a stand-in for this concept in the model, right? Or I use mappings to tell whether or not I need a new class definition. It's sort of way more high level than any kind of machine learning. It's almost like a manual review of these mappings. And so I often have this idea in the back of my head that I'm not sure if I should make these broad and narrow mappings, because I mean, I don't want to distract people from that thing. So usefulness for me has only been at the level of manual review so far, but I know that there's reasons where, like, you know, people that are using data that conform it to BioLink do these machine learning algorithms on them, and they really want those high quality, high effort, domain expert review of these mappings to be able to sort of infer something or do some sort of calculation without worrying that they're making an over assumption. But I don't know where that that boundary is, or, you know, or how to find it. And so I'm trying to figure out if I can use this level of confidence gained from you to kind of just stand in for all of that research I would need to do to understand.
Okay, so first of all, one thing that you are already suggesting with what you just commented is that how important it is before you even go to the lower parts is just to actually write down the various use cases of your mapping, because BioLink has one special problem, which is that it is not only catering to one kind of use case. So it is catering to a documentation use case, for example, where some user, wants to know, okay, is my APO 001, what BioLink category does it belong to, or is it kind of like, is there, do we know where it should go? So it's like a documentation use case, and in this case, you really don't care, you just put mappings and that's it. But if you look at Finio, for example, you want to use the BioLink model mappings to actually assign BioLink categories to your entire ontology. So you want to know, are all of these things genes? Are all of these things phenotypic features? And so on. And in this case, you really do need to know whether you are talking about like precise or some very hazy and vague mappings. Unless, of course, again, in Finio, we don't care about the clear distinction. So maybe we say, oh, we don't really care about whether it is this or that, and whatever BioLink category comes out of it is good enough by us. So, but usually I think it's a good case for saying we need to say which use case this is for. And once you have the use case written down, I do think, yes, you should design your confidence steps, like the average confidence gain. Let's say that's a bit, you could call this analysis paralysis, but I think it's useful to just think of it but like that. I think that confidence gained is confidence that this mapping is useful for your use case. Yes, I do think so.
Perfect, thank you.
All right, so yeah, please feel free to ask more, make more suggestions. I mean, people will see this and say, where's the machine learning, where are the LLMs and so on. Of course, you can put anything in this list here. This is there are like thousands of different techniques that you could use to collect evidence for and against the mapping. You can just ask ChatGPT and say, is this a good mapping? And ChatGPT says yes. And you say, how confident are you? And it would say 0.9. And then you can put this here as well. So it's all of that is of course possible. But this list here is obviously not an exhaustive list, but more like a list that you should kind of like, that gives you a bit of a mental model that can kind of structure your own evidence gathering system for your mapping use case. Sorry, Chris, I wasn't going to talk about that, but obviously, yes. So Chris has developed an approach that actually helps us with evaluating mappings as well. So it can use ChatGPT to really look through a set of mappings and give us a bit and ask it basically what it thinks about it and gives us some more additional confidence. And I think these kinds of approaches, I think we do need to fold them in, because I talked about the expensiveness of full domain expert review, and probably we can drastically reduce the need for full domain expert review if we can exploit the almost kind of expert level knowledge that is embedded in the large language models that we are folding in, and use those for reviewing large swaths of candidate mapping. So you could, for example, gather all of the mappings up top until here, let's say with an automatic technique, and then you can go down here and let some kind of mapper GPT, like the one that Chris developed, go through this and make an expert judgment, which is basically a mental model trained on many different scientific papers that are written by medical experts. So probably quite a good approximation of the full domain expert review. All right, we have 3 more minutes. Any other questions about this, concerns, corrections? You think it's, so I got already from Chris, it's too complicated, but any other perspectives on this? All right. Yeah. Yesterday I tried to quickly put a so any problems that have arisen from conflation of terms via mapping, that's an excellent question. So you have to ask that question, I think, from two perspectives. You have to ask yourself, have you ever encountered a problem from when applying conflation? And you have to ask yourself the question, have you ever encountered a problem from not applying conflation? Because I think these two things are linked very, very closely together. And I can't pinpoint now a specific example, but you can imagine that, let's say, if someone wants to use, here in this example, if someone wants to use Mondo to generate a list of all urological diseases, and all the psychiatric diseases, and then use that to get all the ICD-10 terms related to psychiatric diseases, and then they suddenly get ICD-10 codes in that list that are explicitly absolutely not psychiatric diseases, then you see that a very, conflation is a bit, or maybe a bit badly defined here, but this would lead obviously to a misinformation, so to a problem. But most of the time, I think the problem is the other way around. So if you don't conflate, you will lose a lot of potential for data integration, and you will lose a lot of links that you can use to meaningfully group, for example, information in electronic health records together. That because we need to remember, applying those codes in a clinical context is as hazy a business as it is maybe the definitions of the codes themselves. Different use cases have a dramatic impact. It's another question. Unfortunately, it's now 7 o'clock, so I need to close this meeting. But this is a great question, Chris. Yeah, maybe we should discuss this in a separate call, or we can discuss it in the SOM channel on Obo Foundry. So thank you very much for being here, and talk another time.